Welcome, everyone, to this Professional Development Hour presentation brought to you proudly by the Atlanta Metro chapter of the Georgia Society of Professional Engineers, an affiliate of the National Society of Professional Engineers. Before we begin, we'd like to let you know that any opinions presented tonight are solely the opinions of the presenter and not that of the Georgia Society of Professional Engineers, the National Society of Professional Engineers, or any other of its affiliates. We certainly hope you will enjoy tonight's presentation, so sit back and relax, and on with the show.
Fantastic. Okay. Today's presentation is Lessons Learned from Unexpected Events Related to Bridges. Our speaker is Donn Digamon. He is with the Georgia Department of Transportation, a bridge engineer.
Correct.
Prior to doing that, he spent 15 years as a bridge designer, consultant. And without further ado, please join me in welcoming Donn. I'm sorry, before we get going, one more announcement. If you're going to ask a question, please ask for the mic so we can get the question on video. All right?
Well, just do a sound check. We're good?
We're good.
Okay. And just if I need to speak up, go ahead and then let me know in the back if you can't hear me. So again, my name is Donn Digamon, State Bridge Engineer for the Georgia Department of Transportation. I do see a couple familiar folks here, but I do want to say my thanks for Bill Duvall for connecting me with this group. It was either, I think they were trying to find some speakers, so here I am. And it's always good to speak with fellow peers that understand that we're always going to be in the weeds, if that makes sense. And that's just our nature. And that's a very important statement I'm making, loop back into it at the end of this presentation. But I also want to thank Roger Grabman for just keeping up with me. Probably looked like I was having ADD moments, but there's, as Bill can attest to, there's a lot of emails that come through that demand my attention. But hey, we're all busy at this point, right? There's a lot of things to do, a lot of bridges to replace or to fix, whether it's a truck that hits them or a ship. So let's get started with lessons learned from unexpected events related to bridges. So just a little bit of perspective. The Egyptians and Assyrians were speculated to be the first one that built bridges. And the oldest bridge in the world, and I'm going to forgive me for butchering this, for Arkadiko Bridge, or the Kazarkma Bridge, was an arch bridge over in Greece during the Bronze Age. And then the word civil engineering originated from the 18th century to distinguish between civilian engineering and military engineering. Now I'll pause there, and I'm going to ask a question. I like these to be interactive. Who was the very first civil engineer? And it relates to that date right there. Does anybody know? Anybody care to guess? Was a British citizen. So the fellow's name was Thomas Smeaton, and he fancied himself to be the first civil engineer with that title. So keep on going. So currently we have estimated about 5 to 6 million man-made bridges in the world, and that's probably going to increase with all the funding that's going into infrastructure these days. And currently, now bringing it back home closer to the United States, there's roughly about 621,000 bridges reported in the latest, what we call the 2023 FHWA NBI data. And bring it closer even to our state, there were reported 15,000 bridges that are inspected within the 2023 grouping. Now, just digging down into the numbers, we are engineers here. We don't count bridges that are less than 20 feet in length or 20 feet in opening. So there's probably more bridges out there that the layman would say, hey, that's a bridge, why don't you account for that? In our case, based on the federal codes, which Georgia is based on, we look only at bridges that are 20 feet. Other states will go in and count those other bridges or structures that are less than that. That's their prerogative. That's the way they're set up. Now, the oldest bridge in Georgia is the Red Oak Creek Covered Bridge, and that was built in the 1840s by Horace King. That's still in operation. It's a one-way lane on it, and it's a timber deck. But if you get down to Meriwether County and you find yourself around those areas, this is one of our oldest bridges in the state. Now, getting into the history of state bridge engineers, there's not a lot of us. The first bridge engineer was Sir C.B. Slack. He started around the 1920s, served for about 13 years. There's 11 state bridge engineers, including me. My tenure is still unwritten, so we'll see where that ends, hopefully, in a long career. The longest tenured bridge engineer was a fellow named Clarence Crocker, and he was, after Cersei, the next state bridge engineer. And he did that for 23 years. And I should have brought this up. Maybe he would have shown up, but honorable mention would have been Paul Lyles. He just missed that, or missed tying it by 1 year, 22 years. Speak to him almost every week, just lessons learned. That's how you do lessons learned a lot of times for the younger folks here. Just make sure you don't burn those bridges, pun intended. Do the same thing with Bill as well. Talk to him about history that he knows about that I wasn't there. The average tenure is 10 years, and the shortest or the minimum was 2 years. So not a lot of bridge engineers, but as somebody brought it up, it is a special position that you have, being over a state and their bridge structures. There's 49 other ones besides myself, and two territories, Washington, D.C. and Puerto Rico. So there's not a lot of us. We do have our conference in June up in Indy, so a lot of bridge engineers talking. What do we talk about? Well, you may have to come visit. There's a lot of things going on these days. And even further perspective from the state of Georgia, this is just a report that GDOT puts out every year. It's what we call our AIR report, Accountability and Investment Report. And this you're seeing throughout the years from 2017 up to 2023. This is a metric that is set up part and parcel with the feds, where we're looking at good, fair, and poor bridges. And as you can see here, since 2017, and I'm standing on a lot of work from Bill and some other state bridge engineers, we can see our good bridges percentage go up, and our poor tapering or staying below that 1%, 2% line, and our fair doing the same thing. That said, this is very much a snapshot in time, and as bridge engineers knows, bridges don't stand still. They do, but they age, right? So 2024, 25, where we go further 20 years down the road, these numbers may be different, but it's also maybe the same depending on the funding that we place on maintenance. So that's very important. Learning how to build, design, construct these, but the other part is maintenance of these bridges, and they don't come cheap. So, and that goes back to being good stewards of the Earth's resources, trying to figure out what's our best materials that can do the job. So really getting to the heart of this, everybody's probably seen the channel mega projects, or really don't want to be on those shows where you're showing some collapses, but we all learn from our mistakes, and that's really our teachers, because those are the ones that stick the most. So here, the Tacoma Narrows in 1940s, we had that unfortunate bridge collapse there. The interesting thing about this collapse, you had some very knowledgeable engineers or engineer who were designing this, but part of the lessons learned was there was already lessons learned that when you go too light on too long of a span with these types of bridges, a suspension bridge, you're going to have issues with wind. And this, not just during that day, but a couple years back. So lessons learned that may have been forgotten, at worst may be ignored, and that's something we have to guard against, is that always go back, do your research, talk to folks. There's best practices that you may not know about, and it's always like groups like this, sharing lessons learned, networking, that mentor-mentee relationship, so that you don't have to relive something that has been done before and repeat mistakes. So that was one of the big key lessons learned to Tacoma Narrows. Pay attention to what was done before. There's reasons we do certain things, and in this case, you want to make sure that wind is not your driving design factor. Here we got the Silver Bridge collapse around December 15th. This disaster struck the community at, and I'm going to read through this, Point Pleasant, West Virginia. As people were going home for hard days of work, the Silver Bridge collapsed and caused the death of 46 people. So really just fast forwarding, what this collapse initiated was the bridge inspection that we have today. When they went back and looked at it, it was a single eye bar with a defect that was no more than 0.1 inches that caused the collapse. Now that system itself was non-redundant, if my recollection is correct, but for perspective again, 0.1 inches is the thickness of equivalent to 2 dimes. So even with inspection, that's you have to be due diligent with finding those imperfections that could cause a structure like this to collapse. So the biggest lesson learned here is we inspect bridges every 2 years at most. If there's any defects that we're seeing, it's probably going to be less. Fracture critical, I'll take that back. What's a new term now? Non-redundant steel tension members. That's more than a mouthful, but those are special attention to those types of structures. And an example that's recent, and I'm talking to Baltimore, what happened in Baltimore is this bridge, the Sunshine Skyway in Tampa, vessel collision, right? Here, it's more so, at least in my mind, not what we designed for, is what we didn't design for. And that's really ships that may be out of control or really, truly an uninspected event. So out of that came our vessel collision criteria, really looking at your risk matrix. Hey, and that, I mean, we've had that same conversation with Baltimore, right? Well, why wasn't there a protection system in there? Somebody, I won't say somebody, the whole collection didn't think that there would be an issue with that bridge in Baltimore now, switching gears, being hit. Same thing here. So again, it goes back to Tacoma Narrows that we had lessons learned previously. We just, everything going on, we tend to forget. And I'll tie this up in a bow. I think part of it is what we have today is our knowledge transfer and workforce development. As I see here, we got a lot of great minds here, but I would also like to see a lot more younger folks in our pipeline for the next set of bridge engineers or engineers in general. And 2007, we have the I-30 West Mississippi River collapse up in Minneapolis. Here, the lessons learned, again, focused on bridge inspection. The gusset plates was ultimately what was the issue, but also engineering calcs, QC, QA, and making sure that an existing structure can hold up to new loads. Again, we are engineers, devil in the details. Somewhere in the line, something got missed. That's really not something you want to, as an engineer that would be part of this, to read that, because we're regimented, as somebody alluded to, check one more time, but something happened in that event that we didn't check one more time. Very close to our hearts here is the 85 viaduct. Just personal story, and Bill has his own personal story. I remember leaving that day, it was at 6 o'clock, and as I was walking to the parking deck, the GPS app said, hey, or gave me a warning, hey, your normal commute of an hour is now 2.5 hours. I was like, well, it's Atlanta, okay, I could deal with it. But as I was turning north, I saw the plume of smoke. So, well, let me turn on the radio. That's how I got the news that we had a bridge fire. And very interestingly enough, the GPS actually forced me towards that location. Don't know why, but got to see it up front. took about 2 hours, roughly 2.5 hours to get home up in Buford. And then I got the call and then turned to my wife, said, yeah, I'm going back tonight. And Bill and I and another colleague, Steve, I don't think we slept until, I'm not sure when we slept that weekend, but again, lessons learned, couple things. Well, storage of flammable material. In this case, even the materials aren't flammable, but if you get it hot enough, it will ignite. And so, but again, we've also already had some, I won't say copycat events like this, but you talk about the Caltrans fire over at Los Angeles, same idea or same event, and we still have these fire events, and that involves the homeless. That's for another presentation, because that is a very hot topic, unfortunately, pun intended on that, that we're trying to solve for a lot of bridge engineers, because we've had some bridges, new bridges, taken offline just because somebody got in there and started a fire. So again, more so lessons learned here, storage, but also some good lessons learned, how quickly we can respond to an event, a collaborative nature between agencies, and how quickly you can get plans and repair when you're collaborating with the contractor on site. And that kind of goes into the concept of design build when you've got a focus group trying to get things done in a very timely manner. So, and I wouldn't have to say, but we did that in 6 weeks, we being a contractor and GDOT, and great lesson for young engineers. I mean, we had, I think, Bill, quite a good bit of young engineers there. They're still there, and it's hard to replicate that on the resume, as you know, some of these folks will go out into consultant world. And trying to tie this up, so lessons learned, you know, the current state of the workforce for bridge and structural engineers, just looking at the bridge office now, it's roughly 75% where we have folks that are 10 years or less. Now, Flash, when Bill was there, I think about 5 years ago, that was the other way around. So it quickly changed around in 5 years, where we had 65, 75% that had 30 years of experience or 20 years of experience, and now we're on the reverse. So that is something, at least in my focus, that we need more, and I've talked to folks here, we need more engineers in the pipeline, because you can't create, as much as some people say, you shake a tree over at close to where we're at, and with the proximity of Georgia Tech, you have a civil engineer. It takes a little bit more time than just the, you know, the college years. You have to get into the practice to learn, to get exposure, to meet folks, to be your mentors, and ultimately become a mentor yourself. That you gain from experience, and that's, frankly speaking, that's what companies pay you for, and that's really your skill set to be a civil engineer. I've alluded to before, knowledge transfer. That's going to be a key component, because folks are retiring, and we need that transfer between folks who know, who've seen it before, and the folks who are trying to learn it. So try not to reinvent the wheel, so to speak. And workforce development, again, just getting folks in the pipeline, getting folks interested in engineering, understanding for some folks, hey, it is very, I guess the catchphrase, it's very cool to be part of something bigger. Hey, I've designed that bridge, or I helped inspect and construct that bridge. And these are monuments. They'll be out there for 75, 100 years. And some of our older bridges, as you can see, have been out there for more than 100 years. And somebody alluded to it, it's a safety focus. This is near and dear to my heart. We've got a lot of work going on. There's a lot of pressures to deliver on time or even shorten. But like the oath says, it behooves you to do your best to be able to do the best job you can do, especially for these structures, because at any time, any of your family members can be driving over these bridges, and you really don't want to be to hear those news that there's a collapse. And then this is more for discussion after getting close to the end of this presentation, but a few of y'all were at a seminar that we hosted over at GDOT for American Segmental Bridge Institute, or Precast Concrete Institute. But this idea by Diane Vaughn about normalization of deviance. So she does have a book, and I didn't get to read it yet, but there was an example of the space program, and they've had a series of failures, right? And really what it gets down to is that we get so successful with certain things, but we also get away with certain things. So yes, we're designing to an edge, we put up a bridge, hey, nothing happens for 10 years. Keep repeating that same design. Well, then you have a failure. And then we go back, do forensics, like, well, why didn't we catch this? Well, it's just that normalization of deviance. We think that nothing has happened, keep going, and then oops, something happened. So for folks that are seasoned, to the folks that are just getting into it, as an engineer, always in the weeds, always question, take a step back, have a micro and macro view, if that makes sense. But the biggest thing that, at least for me personally, is these networkings that you have. It's a lot, it helps me when I can talk to Bill or to Paul or other folks, say, hey, I'm bouncing an idea. Is this a good idea? Have you seen it? I'll call up folks out in Alaska DOT when they're talking about seismic. I'll talk to Caltrans. It's that networking as an engineer, especially in this case, a bridge engineer, that you can reach out and talk to folks, and you can see whether you're out on the line or you're within that sandbox that you're supposed to be playing in, that safety zone. So that's all I've got for tonight. Hopefully it was at least engaging and spur some discussion. So any questions?
Can you talk us through some of the inspection regimen? I'm sure visual is some, but what else do you do beyond visual, and how does even a visual go when you're talking about looking for 1/10 of an inch faults?
Well, I'm glad there's a couple bridge inspectors here, right? So I'm looking at one of them or two of them, but yes, there's the hands-on, but then there's, when we get down to it with fracture critical, there's some non-destructive testing as well on steel structures. I mean, you get a hammer and start sounding out concrete for whether it's delaminated or spalled. Yeah, there's a lot of hands-on to it. It's every 2 years that we look at bridges. And for certain bridges, we go less than that. For example, we had one up in Fanning County where we're about to close it. But this is where, as a civil engineer, that civil part, right, you're always interacting with the public. That was the only way into that area. So we were asked by our leadership to look at it again and assign it. Well, you can get any vehicles that are 3 tons on this, but that's it. So thankfully, we've got that replaced. But you know, hands-on measurements, hammering of delaminated concrete, ultrasounds as far as non-destructive, whether it's concrete, steel, wood. There are different types of testing involved as well. Hopefully that sort of answered that question.
You mentioned earlier about the bridge here in Atlanta that had a fire. And let's face it, almost every vehicle that travels down the road either has a tank full of gasoline or a bunch of cobalt lithium-ion batteries. Is there anything that can be done in bridge design to help make it withstand that type of heat?
No, that's a very good question. For a singular vehicle, I think our normal design captures it. But when you, let's say if you're storing a lot of those the EV or battery vehicles with batteries, and you get a fire underneath the bridge, I don't think you can design for that. So that was part of our lessons learned. Do not store anything that it could be flammable underneath our bridges. And then that got further reinforced when the Caltrans fire happened. So going back and looking, and part of it is inspection and reporting. Hey, if inspectors are seeing piles of wood or pallets underneath the bridge that shouldn't be there. Report that immediately. If it's a state-owned bridge, we're able to remove that. If it's a county-owned bridge, or if it's, I'm just going to use an example, railroad right-of-way, then you have to coordinate with the necessary agencies. But to answer your question, you could try to have extra cover. You can try different painting systems like intumescent paint, but that's just buying you time. That's really buying you time for first responders to get there.
Back in 2022, the governor and the legislature decided to help out the commodities folks and the lumber industry and stuff by increasing weight limits from 80,000 pounds to 88,000 pounds on a bunch of bridges. And I think somebody wrote up something that said that about 700 bridges can't withstand those weight limits. Are we doing anything about that?
So, and that's a good question. So it's all, what he was asking about was the increased truck weights that happened in 23. As response to that, we posted all those bridges for weight limits. And in our normal procedures, one of the things we look at for replacements or rehabs are posted bridges. So they're going through the queue, so to speak, as far as whether that bridge needs to be replaced and then, or rehabbed, so to speak, to get it up to strength so those trucks can go over it. But that takes time. So 700 bridges that were additionally posted, that we already had about 1,600 that were posted previously for defects.
But the law allows overweight trucks to drive over.
No, not on those. Once we post them, they're not, it is enforceable if they're seen crossing that bridge, to be fined for crossing that bridge. But technically speaking, if it's posted with a sign, they're not supposed to be crossing over it.
Years ago, we did have a speaker who was a bridge inspector. And one of the slides he had was a limited bridge that they were inspecting. And as they were inspecting it, a heavy-duty logging truck went right over it,
Yep.
much to their anxiety as they did so. Yeah. Where's a police officer when you need one, right?
Well, it's like a lot of the state agencies, it's about funding. It's you need more enforcement, and it's just we all have to put forth and say, hey, if it's something it's very important to have enforcement. But at this point, I forgot what the figures were, but I think for every enforcement we had, they would have to look at 500 miles of road. So it's very difficult.
You mentioned the Silver Bridge. How did you describe that again?
What's
the Silver Bridge?
The Silver Bridge?
Its
yes.
construction was, you said an I-plate? That was the term?
An I-beam.
Okay.
Yeah.
It was a suspension bridge with a big chain made out of plates, right?
Correct, yeah.
And it was susceptible to, it was required maintenance, so its design was susceptible in that regard.
Correct.
I went to high school outside of Pittsburgh. There are a number of bridges across the rivers in Pittsburgh with similar plates, but not a single plate in any strand, and multiple strands. So that learning is like, you have to consider what's it going to be required to maintain, right?
That is correct, yep.
So what are some of the highlights that you look for when you're looking at bridges in that regard?
Well, as far as putting into service newer bridges, we're looking at, hopefully this answers the question, redundant systems, where if there's an issue with one component, then it's not necessarily going to make it where it's a catastrophic failure once that component goes down. So to that point, we do have some fracture critical bridges, but those have a special focus on them to be replaced. And I think Most of them, maybe only a handful, are in the replacement. They're identified, they have project assigned to them for replacement. So as far as our focus here for the department is to identify and replace those non-redundant bridges.
Regarding railway bridges,
Okay.
how's the responsibility for those shared between the DOT and the Federal Railway Association?
Oh, that's a very good question. So the railroad bridges are under responsibility of the railroad, even if they go over our roadways. It is, and it's, I'll bring this up, recent interaction, the 5th runway at Hartsfield is technically owned by Atlanta Hartsfield Airport, Jackson Airport. But speaking to their, I guess their engineer, we both understand that if something were to happen to that structure, it behooves us to be able to say, hey, we collaborated, we have a procedure, emergency procedure in place. If something like that were to happen, that it's very much coordinated between agencies, between enforcement, between EMS. So there is, to your question, a sharing of responsibility, but technically speaking for railroad, that bridges, that is their responsibility. As far as FRA, that I haven't seen personally the interaction with that. So fortunately, I can't answer that part.
Thank you.
I had read somewhere that Roebling had a problem with counterfeit material. The supplier of the cables was making substitution for, they would test a lot and then substitute the coils on the wagon and deliver them. They eventually got caught. Is that a bit of a problem for the bridge industry?
I would say no. We have a very diligent set of staff that look at the material inspection of our bridges, and that's just for a lot of DOTs as well. I'll put it this way, we put a lot of investment in our design. You also need to put a lot of investment in making sure you realize your design out in the field. And one of that is inspection. The other part is, well, materials inspection. The other part to that is construction inspection. That you have to have folks that know how to read the plans, the intent of the plans, and how that translates to what you're building. Hopefully that answered your question.
So, and I'm not trying to put you on the spot with this one.
I'm used to it.
Don't answer if you can't, but the I-85 bridge that you talked about, that was rebuilt in
6 weeks.
what everybody understands is record time.
Yes.
Because a lot of rules were lifted.
Okay, keep going.
So, kind of, I don't know how you want to approach it. What's your opinion? What's your take on it about some of the rules? As I think most people recognize, it was done safely.
Yes.
So if it was done safely and done in that short a period of time as compared to some of the other bridges we see that are taking years to put up, are those rules really needed, I guess, is really what it boils down to.
They are needed. There's only a limited amount of funds, and that project did cost more than the normal, obviously because of sense of urgency and just the importance of that link that it provided. I forgot, Bill, how many vehicles there were per day. It was pretty high. So, and you could, as commuters, you could feel it because the detours around it were not a lot of fun. But yes, it's well, to that point, it's one of those things. Those successes become some of our hardest lessons learned. Yes, we can do it quick, but to do it on each project will certainly increase the cost, and then there'll be reduced amount of projects that we could do because of that increased cost. That said, What we learned out of that is that doesn't cost a lot. It's just better communication. I mean, that should be a given, right? But we keep forgetting about that. Collaboration, just understanding, hey, the viewpoint of somebody else across the aisle from you, whether you're doing negotiations for liquidated damages or, talking to a contractor, hey, based on my equipment schedule, my folks, I can do this a lot quicker doing it this way versus our expectation as a department. So really being able to sit down across from somebody and be able to be collaborative. It's a word that's easier said than done, because we do have our preconceived notions, and a lot of times that's where the best work is happening, is when you let some of those preconceived notions go and start listening, if that makes sense.
So now, sorry, real quick follow-up. Is part of that then, so you say there's a cost to benefit trade-off there.
Yep.
Is the time and the impact on traffic, is that really accounted for in that cost to benefit? Because yeah, it may cost a few more dollars up front, but how does that compare, or is it offset by the impact to the society overall?
That's a very good question. Looking at it, do we do it for every project? No, but a good example, and apologize right now for the folks here that have to live around North Druid Hills, but that right there was a prime example alongside Northside Drive, where we looked at user cost. Whether, all right, if I do this the normal way, drivers would experience 2 to 3 years of staged construction, or if I do it in 90 days, close it off, let the contractor work. It's for him or her, for the contractor, it's about safety. He's not having to deal with moving lane closures, and they can just get it done. There is a cost to that. We have some other projects that have more stringent criteria than that, and we're trying to work through it, but we're looking at some places, very busy roads, we're trying to close it for 6 weeks just to replace a bridge. So not on every project, but that is part of the metrics, the culture of looking at, hey, what's our best approach? And it's not just one stop fits all, it's more like I would say a dial or a slide, where it's like, all right, for this project, we'll look at certain things, whereas for a major project, yeah, we're pulling out the stops. So it's whatever fits a lot of time.
This is more of a supplemental comment to what you're saying rather than a question, but the public scrutiny on public projects, whether it's DOT, MARTA, the Department of Aviation, or whatever, is very strong, and the budgetary process and so forth for projects is a huge part of project delivery. And I don't think what is really being recognized here on the I-85 bridge issue is the road was closed. So it was an emergency, and a lot of the normal considerations for a project didn't need to be considered, and the rules that were being broken were more administrative bidding rules, that sort of thing, the competitive bidding aspect of it. And you had a partnership with contractors with proven track record, with a high level of quality. The resources were here. The ability to get mobilized very quickly is something that was very fortunate, and it wasn't risking quality to the project. And of course it didn't just cost a little bit more. Those types of accelerations add a gigantic exponential premium to project costs, and the public and the budgets can't do that. I was just reading in the paper today, it was an older article, but the Express Lanes project that's coming up for Georgia 400, and how that's been tabled twice because bids had come in so far beyond budget. So anyhow, I just wanted to add that.
No, I appreciate it, and I'm glad you brought it up. So relaxing, yes. What wasn't relaxed was the engineering codes. Now we worked through materials to say, hey, let's use concrete that can get accelerated strength so we can open the bridge quicker. But yeah, the engineering philosophies, the approach was still the same. Yes, sir.
Still on the I-85
Yes.
replacement, the speed that was discussed, that's one of those cases where you could reuse plans that
Correct.
were already available. You did not have to go through a design process per se and an environmental, with all the steps that go on with an environmental process to get approvals.
Correct.
Right, so that obviously helped quite a bit in the speed at which it was able to get put back in place. Right?
You're correct, yeah.
Absolutely. Okay.
Yeah. Now well, let me expound on that. I mean, a lot of it, yes, we had existing plans, and again, it was great to see these younger folks go in and chime in into this unfortunate event, but lending their expertise where, and Bill can allude to this, we used to do repairs. We would take a Sharpie and get those old plans and then scan it in. Well, some of these younger ones figured out, hey, I can reference this into our CAD software and be able to draw on top of these scans and do that a lot quicker rather than just doing by pen. And again, did that on the fly and really doing that quickly. I think we got the plans out in 3 or 4 days, and we were already doing beam shop drawings that Sunday night. So yeah, it was really a team effort. Yes, sir.
I moved here to Atlanta about 25 years ago, and when I moved here, I was told that the number of bridge crossings in the Atlanta area over the river was fewer than we had 100 years earlier.
Huh. Okay.
And so my question is, does your office get involved at all with bridge siting, such as, is the soil good in this area, should it be moved, or anything like that?
Can you repeat that again? Sorry.
Does your office get involved before the bridge is completely settled on and decided to be moved, such as siting the bridge? Should we put the bridge here or should we put the bridge there?
Yeah, we are part of that process.
Can you expand on what your office does with regards to pre-building of the bridge?
Well, I'll take that back. A lot of times it's driven, if it's a new alignment, I mean, a lot of times it's just, hey, roadway comes out, here's your bridge crossing. Sometimes we'll tweak that as we go through and say, well, you may want to cross somewhere where your bridge is a little bit less, because in a project, cost of bridges are a lot higher dollar amount. But granularly speaking, the bridge office has a group that does bridge hydraulics, and in the weeds, so to speak, they're the ones sizing the bridge for the site. Does that answer your question? Okay.
I want to follow up to what David was asking about, and about the 85 in re-engineering. Yes, we did have a lot of information available. We had a very good connection between the department, the contractor, and my name's Bill Duvall, and also with the fabricators. Well, yep. So we got into it early on, and Donn led the design, and he and his group led the design for the pre-stressed beams. And so the actual original pre-stressed beams, I think he had, it's been a while, probably like 58.
Yeah.
But you had like 58 different designs.
Yeah, the spans had trapezoidal spans.
Trapezoidal spans. So yeah. and so every beam in multiple spans were different lengths, and so we changed from a Type 5, modified Type 5 beam to AASHTO boltese. One, because the forms are available. Two, because it's what the industry is using. So he had to design and run a group that designed every one of those beams. And then at the same time, while we're designing beams, we're talking with the contractor who is set up with the fabricator. So we're, like Donn said, in 3 days we had not only plans out the door, we had shop drawings coming back in. So I mean, there was a lot of design in a very, very short time.
Yeah.
But also great collaboration between and throughout the industry.
I mean, with the bridges aside, I mean, you had the response from traffic ops making sure people were still able to go through there, restriping of certain roads so that you can get more volume through. We also learned that GPS will send you through neighborhoods, so I mean that's another lessons learned as well. If you look for it, there are lessons learned, whether you look at it as bad or good, but it's the part that to be always focused on. Hopefully you don't forget about those lessons learned.
You had used, in conversation we talked about knowledge management.
Correct.
Lessons learned. That applies to all the fields of engineering. The majority of the people here don't work on bridges.
Correct.
So can you give some sort of general idea of how people should manage the knowledge that they're finding? I guess we're talking about newly discovered knowledge or rediscovered knowledge.
Well, it's as simple as this, at least the way I see it, is that mentor-mentee relationship is, as seasoned engineers, you've gone through the tribulations, you went through the equation, say, hey, this doesn't make sense, but hey, if I do this, this works out. It's not written anywhere. Let's face it, all up in your head. But to pass that on now, I've learned knowledge is not easily transferred because, it's not easily gained as well. And the best teachers of lessons are the ones that are hardest, or I won't say hardest, but earn the most rigorous way because you remember them. And so that's kind of knowledge management. I'm talking about knowledge transfer is for the younger staff, really. And I say this a lot, especially for construction. Go back to bridge construction. Always encourage, and Bill did this too, for our younger engineers to go out to construction. And I learned this: the construction folks will not talk to you the first, second, third, or fourth time you're out there. It's probably the fifth or sixth time that you say, hey, we've seen this young engineer, he or she's been out here, he's asking some good questions. Then they'll start talking to you. But whether it's in the office or really out in construction, those are the folks that you want to talk to because it's taking now your designing concept and actually building it, whether it's inspection for a DOT or a contractor. It's easy to sit there and look at a machine or draw something that's a footing that's 10 by 10 by 5, but to actually see it, to form it, to put rebar in it is a different story. And you learn a lot of things when you design and also construct that way as well.
I'm definitely not a structural engineer, but different disciplines, we see some things. And one thing that didn't come across in your presentation, when folks started talking about Interstate 85,
yep.
Georgia DOT interaction with the federal agencies. So when we talk about tribal knowledge, how are we taking advantage of the expertise of structural engineers nationwide? Is there some federal standard over you, so when you're doing your design, it has to be in compliance with, I assume, federal guidelines, what you can do and what you can't do?
So I alluded to, actually, I should have done a better job. There's an organization called AASHTO, American Highway Association, and there's a bridge component to that. There's roadway, bridge, traffic ops, and we're meeting, we meet annually, and we're meeting in June, and you're talking about, again, 50 states plus 2 territories, and that's where you get that knowledge share.
Umbrella organization of
Yes.
all the states.
Yep. And that same organization has specifically for bridges what we call the AASHTO LRFD Bridge Code that governs all our designs.
So we've talked a lot about reuse and lessons learned. Now, I'm an electrical and computer engineer, and we use a lot of modularity in terms of reuse, whether it's open source or within a company.
Yes.
So there's a lot of building blocks that we reuse, so we're not having to reinvent the wheel every single time. How much of that goes on in bridge building and design, really?
Well, I would say this from our history, specifically for Georgia DOT. For a long time there, we had bridge design software that was Fortran based. And that worked for how long, Bill? I mean, decades. And that streamlined a lot of our designs because the consultant doing the work learned how to use that software, and also the DOT folks that would be checking it were already very experienced with it, and they could spot issues or input errors right off the bat. So you're talking about that modularity. There's standards that we put out there that helps out with, again, consistency, whether it's a set of standards for bridges or you're looking at guardrails, retaining walls, or roadway design. That helps with that modularity, that consistency as well.
Historically, there have been certain concepts of bridges that were common. Camelback bridges 100 years ago. Mm-hmm. You look at the interstate bridges that go across interstates now, they all look very similar.
Yep.
Must be a reason.
Yeah, we copy, if it doesn't work, don't fix it. If it's not broken, don't fix it, right? So, yeah. Use it again. Use it again and again, yes.
One of them,
if it ain't broke, don't fix it.
One of the more bizarre ones was the bridge that was stolen in Gwinnett County.
Say that again.
The Gwinnett County bridge that was stolen.
Huh, okay.
Yeah, Jones River Bridge, half of it was stolen in the 50s.
That I didn't know. Bill, you knew about that one? Yeah, we weren't inspecting at that point, so yeah, that wasn't in an inspection report.
Was it on a state highway?
We could be that too. Yes, sir.
What might be a lessons learned you have from a non-catastrophic failure?
Ooh, they usually come, well, I mean, non-catastrophic, so I don't know if Bill was holding back, but after I got selected for this position after Bill retired, there seemed to be an uptick on bridge hits. Not sure why exactly, or it's just my bad luck, but they're not catastrophic, but understanding lessons learned, again, it goes back to just how quickly, if you assemble the right members of a team, you can respond to an event. So I think Bill was there at that time still. We responded to a bridge hit down in Bainbridge, Georgia, and in 2 days, 2 or 3 days after the event, we had plans for repair. And it's usually around, that's probably the quickest we did, but anywhere from that to 10 days, we can assemble real quick internally and do repair plans. Whether it's a concrete bridge, steel beam, we also respond or help respond when they hit these what we call overhead sign bridges. You see them all over the place. Anything that can be hit, unfortunately, they will hit out there. And vertical clearance doesn't matter. We learned that on a bridge over I-16. That bridge hit with its dump truck bed up could have hit a bridge with a vertical clearance of 23. I'm speculating on that, but it was, yeah, it doesn't matter. And we're at awe at how these dump trucks do have sensors that warn you that your bed is up, but we have videos of them on a couple occasions where they hit a bridge and their beds are up. So.
Now, I had a question. Mm-hmm. In the performance of your job, what do you find to be the long pole in the tent? Is it budget? Is it manpower? Is it regulations?
You're naming a few of them. All the above, a good answer. Right now, I mean, certainly budget, certainly regulation, but to me, I guess, and if it's not abundantly clear, the focus is, what I'm seeing is the generation of engineers coming behind me. There's not a lot of them, and that's a problem. So, yeah, we can have all the funding in the world. We're seeing it right now. We have some folks see it as the historic funding on infrastructure, but there's only a certain amount of engineers that we have. And to get all that work out, hindsight's 2020, right? We should have invested probably a couple of years back, but there's some other things that were happening as well that didn't help. So, yes, sir.
Specifically on that issue, some of us have sat around and talked about this quite a bit and speculated, is it that the person that would have been an engineer 30 years ago is now going into computer science or into robotics, or, is it an attention thing, or is it maybe a, reluctance to take on the liability for some of these bigger structural jobs? I mean, in your opinion, what do you think might be contributing most to that deficit?
Probably same as previously before, all of the above, but I'll provide this story. You remember that story where, hey, somebody asked, do you want to be a chair? And everybody takes a step back, and you forgot you take a step back. I was that one. So I'm a chair for AASHTO, Knowledge Management and Workforce Development. And what we're looking at is we've got to have, yes, we can try to get folks to get in, right off the bat from colleges. But really, if we were going to have a better future advancement of our profession, we have to start selling ourselves a lot better. And that's going into high schools and elementary schools. I mean, let's face it, when you're looking at your own kids, it's what's the number one professions? Doctor, lawyer, and probably those two, and financiers, right? Engineers not in there. We have to do a better job at selling that it is a worthwhile profession. You do have a large effect on your daily lives, your family, your friends, or acquaintances. None of this would work without a system in place, whether it's civil, electrical, mechanical. I mean, let's think about it. If there's no AC, we would have a lot more crankier folks, right? So.
To the point of workforce development, if anybody knows somebody who's an engineering student, even the high school senior who's already enrolled for the next year, they do get a free membership nationwide in the National Society of Professional Engineers. That includes here in Georgia, GSPE. NSPE.org, hit the join button, join as a student, put in a future graduation date, it's free. Also, companies have the ability to post internship and co-op opportunities on the GSPE job board at no cost.
Any other questions?
I'd like to make an announcement if I could.
After the presentation. Okay. Great. Well, thank you very much, Don.
Well, thank you.
Great presentation. Appreciate it. And if you would, please accept this small gift as a token of our appreciation.
All right. Thank you.
Thank you so much.
Thank you.
All right.
We hope you enjoy. We hope you enjoyed this presentation given at one of the Atlanta Metro Chapter meetings of the Georgia Society of Professional Engineers, an affiliate of the National Society of Professional Engineers. To find out more about us or to join us, check us out at gspe.org.